Imagine soaring at 35,000 feet, cruising at over 500 miles per hour. Outside your window, the air is a dynamic, ever-changing ocean, full of currents, waves, and turbulence. For decades, airplanes were built tough, but they couldn't sense the sky around them. But what if a plane could feel? What if its wings sensed every shift in wind like your skin feels a breeze? This is no longer science fiction, it's happening now, thanks to materials science. Materials have always mattered. Strong swords, heat-resistant pots, lightweight airplane wings. But now, we're creating materials that do more. They sense, respond, and adapt. Today's airplanes are evolving into machines with their own nervous systems. Instead of nerves, they use smart materials, embedded in wings, fuselage, and tail. These act as nerve endings, constantly listening to the sky and reporting back on the plane's health. This shift, from passive machines to sensitive, responsive aircraft, is a revolution in engineering. Scientists saw potential in crystals and glass, turning them into materials that talk to us. These innovations keep us safer and make flying more efficient. So let's explore how we taught airplanes to feel the sky. It's a story that will change how you see flight. What is a smart material? It's a substance that changes its properties when triggered by something, like heat, pressure, or electricity. Think of glasses that darken in sunlight. The lenses sense UV light and respond by changing color. That's the core idea. Sense and respond. Now scale that up to an airplane. We need materials that react to the forces of flight. Pressure, vibration, temperature. These materials don't just sit there, they're active participants designed at the molecular level to interact with their environment. The real breakthrough is learning to manufacture and integrate these materials into complex machines. Scientists are now material architects, designing substances atom by atom for specific tasks. Imagine a metal that remembers its shape or a ceramic that generates electricity when squeezed. These aren't just improvements. They're leaps that make our machines smarter and safer. Smart materials let us build things that are lighter, stronger, and intelligent. This intelligence is making airplanes safer and more aware than ever. Welcome to the age of smart materials. Let's meet the smart materials inside an airplane's sensory system. First, piezoelectric materials. Squeeze them, and they generate electricity. Apply voltage, and they change shape. These are perfect for sensing pressure and vibration. Tiny sensors scattered across the wings and fuselage. Every gust of wind or bit of turbulence creates electrical pulses, giving real-time feedback on the plane's condition. Next, fiber optic sensors. Thin glass strands that sense changes in strain or temperature by altering light signals. Embedded in a wing, a single fiber can act as thousands of sensors, mapping stress and temperature along its length. These materials act like nerve endings, giving engineers a detailed picture of the aircraft's health. It's a continuous, silent conversation between the plane and the sky. That's the magic of smart materials. So how do these materials create a nervous system for airplanes? Sensors, piezoelectrics, and fiber optics act as nerve endings, feeding data to the plane's onboard computer. This system, called structural health monitoring, constantly maps stress, strain, and temperature across the aircraft. Imagine a gust hits the wing sensors send instant signals, pinpointing the force's location and intensity. The computer compares this data to normal patterns, learning what's right for the plane. Enter shape memory alloys, metals that remember their shape. Heat them, and they snap back, acting as tiny muscles. If sensors detect a problem, these alloys can adjust wing panels in real time, smoothing airflow and boosting efficiency. It's a living feedback loop, sensing, thinking, and responding. That's how planes feel the sky. What does all this mean for you? First, safety. Planes now monitor themselves every flight, spotting tiny cracks or stress before they become dangerous. Maintenance shifts from scheduled checkups to real-time targeted repairs, fixing problems while they're still small. This makes flying safer than ever. Smart systems also boost efficiency. By sensing turbulence and adjusting wing shape, planes reduce drag and save fuel. Even a small drop in drag saves millions of gallons of fuel and cuts emissions. That's good for airlines and the planet. Smart materials are leading aviation's green revolution. Safer, lighter, more efficient planes mean a win for everyone. That's engineering with a conscience. We've gone from smart materials to airplanes with their own nervous systems. But this isn't just about planes. These ideas are shaping bridges, medical devices, and even space exploration. The next breakthroughs will come from new materials, ones that capture energy, heal themselves, or survive on other planets. The next generation of innovators, maybe you, will design these materials. Get curious. Explore science, build things, take them apart, ask questions. Every why is a doorway into material science. You don't need a PhD to start, the world is your lab. Next time you see a plane overhead, remember, it's a marvel of sensing and human ingenuity. The future is built from new materials, one discovery at a time. So, go out there. Experiment, invent, and help build a better world. The sky's not the limit, it's just the beginning.